Hello, everyone. Welcome to my presentation. My name is Juan Dong. My topic is reliable data transmission solution for wireless sensor network and security of WSN vulnerabilities. So, wireless sensor networks are now a very popular research area, but there are still some unsolved challenges from the perspective of hardware, energy consumption, and battery life are issues that need to be paid attention to when a node is produced, and how to combine technologies to achieve low energy consumption, reduce node complexity, and most importantly, ensure reliable data transmission is a long-standing problem. And because the realization of WSN requires a large number of nodes, how to ensure the production cost of each node is within the controllable range is also one of the key points. So here comes why I want to make some research on this field. The wireless sensor network is an essential component of the new generation of networks. As a novel network model, it has a wide range of potential applications and the potential to advance society and science and technology. For instance, in military applications, the wireless sensor network has good fault tolerance and self-organization because it is composed of dense, low-cost, randomly distributed multi-nodes. These characteristics ensure that some nodes will not be damaged, resulting in the system's collapse. The wireless sensor network is well suited to meet the accuracy and comprehensiveness of military information acquisition because of the increased concealment and rapid development capabilities brought about by the small scale of sensor networks nodes. Performance and requirements in real-time second. The wireless sensor network also plays a very important role in medical, environmental, family, and other applications. It is related to national, political, economic, and social security and has become the focus of international competition. However, when WSN transmits data, there are problems such as exclusive consumption of transmission bandwidth, energy consumption, delay, and security. And one of the most vexing problems is data loss and corruption. These abnormal conditions of data and caused by different reasons, including unreliable and unstable data links, noise interference, and data collisions. Even though there isn't a perfect solution, increasing the security and dependability of data transmission will greatly accelerate the use of WSN in a variety of fields. So here is the background. As early as the 1970s, point-to-point transmission and connected sensor controllers formed the prototype of the first generation of sensor networks, which we attribute to the conventional sensor. Because of ongoing advancements in related fields, the sensor network also has a complete processing capability to obtain a variety of information signals. Sensor networks are in their second generation right now. Sensor networks have utilized the field bus technology since the turn of the century. It is utilized to construct intelligent sensor networks, wireless technology is used to connect a lot of multifunctional sensors, and wireless sensor networks start to form. The low energy wireless integrated micro sensor was submitted to DAR in 1996 by UCLA University professor William J. Kaiser, laying the groundwork for the current WSN network from the perspective of network research. Professor Roger J. Potty re-attempted the scientific significance of WSN in 1998. Now humans are already living the information age. As technology advancement continues to accelerate, the most fundamental and crucial technology for information acquisition, sensor technology, has also undergone significant development. And information revolution will occur as a result of the sensor information acquisition technologies gradually shift from simplification to integration, meaning. So that's a background. Let's get into the research question. The research question is how to manage the reliable data transmission. Conversely, so to solve the problems, there are two solutions. So ZigBee is the first solution, and the second solution is change the node design, which replace the current design to a better design. Let's talk about the ZigBee first. So the brief distance low speed remote organization convention known as ZigBee physical layer, middle access control layer, transport layer, network layer, application layer, and so on are parts of the ZigBee protocol. It has closeness, low intricacy, self association, low power utilization, and low information rate. Among other characteristics, most reasonable for programmed and controller applications. It very well may be implemented in an extensive variety of gear. So numerous low-cost macro sensor modules are placed close to the object being sensed to make up the sensor node. Its function is to send the sensing object's information to the sync node via cooperative sensing, collection, and processing within the network converge area through wireless communication. Each module creates a self-organizing network system with multiple hops. The data that is collected by other sensors nodes is transmitted hop by hop to the sync node. A WSN system typically consists of a large number of small, inexpensive sensor nodes. Each sensor node not only processes data and gathers information about the local environment, but it also stores, manages, and fuses the data sent by other nodes and collaborates with other nodes to complete specific tasks. The wireless sensor node is made up of energy supply modules, information processing modules, wireless communication modules, and sensor modules. The processing, storage, and communication capacities of the sync node are relatively robust. It serves as a gateway between the sensor network and external networks, such as the internet, to carry out the conversation between the two protocols. It also publishes the monitoring tasks from the management node to the sensor nodes and collects the data collected by the WSN. The data is forwarded to the outside organization. The sync node can be a sensor node with enhanced functions, a sufficient energy supply, and other features in order to conduct confidential analysis of the program code, routing protocol, and key that are stored in the sensor nodes simultaneously. The computer receives all data stored in SRAM and Flash, and the assembly software make it simply to convert the acquired data into the assembly file format. The management node is in charge of dynamically managing the entire wireless sensor network. The owner of the sensor network has access to the results of the wireless sensor network through the management node. After analyzing and thinking, another way to solve the reliability of wireless transmission is to use better sensor node design. Although the design of sensor nodes varies according to specific application, the design philosophy is the same. In general, there are several basic points that must be considered in design of wireless sensor network nodes. As an important part of wireless sensor networks, sensor nodes should consider the following characteristics when designing. So the first is condensation. So to avoid affecting the characteristics of the target system, the application sensor nodes must have a high degree of the integration. And the second is low use of energy. Due to the fact that the wireless sensor network is frequently deployed in unattended locations, the nodes are powered by batteries that cannot be replaced frequently. And power consumption has a direct impact on the node's service life. As a result, the application's main issue is how to cut down power use. The third is minimal expense. The network has a large number of nodes, so the cost per node cannot be excessive. This also means that the sensor node configurations hardware resource should not be too high. It's hard to find a balance between different hardware resources to meet functional requirements at a low cost. And the fourth is high strength. So sensor networks are distributed in a wide area, often affected by the natural environment. Maintenance is very difficult, and some nodes may die due to some reasons. So the nodes are required to have a certain survivability. And the fifth is scalability. Sensor nodes can be equipped with a variety of sensors according to different tasks. Therefore, the extension interface reserved by the node must meet this requirement. And providing scalability is also a great help in saving costs. The last but not least, high trustworthiness. Data transmission reliability is critical for important applications like the military and fire and disaster resistance that rely heavily on wireless sensor networks. So basically, that's the solutions. And coming to the conclusion, in order to allow WSN to enter the application industry faster and serve more people, it is necessary to focus more on improving the application requirements of automatic monitoring, inspection, and management in mature industries, while striving to find unique killer applications, tailor-made protocols, software, and products, and strive to achieve seamless connection with existing management systems. Only by gaining a firm foothold in application and markets can the continued development of WSN in technology be maintained. Thank you for listening. That's the presentation.